Okay, so in this problem, we're being asked to find the volume of the solid obtained by rotating y equals 1 over x between y equals 0, x equals 2, and x equals 4, and we're rotating about the x-axis. Okay, so first, let's draw a little picture of. So over here on the side, I'm going to draw the function 1 over x. And so the function 1 over x looks something like this. Okay, and then if we chop it off according to what this tells us, so this tells us that it's between y equals 0, x equals 2, and x equals 4. So let's just pretend like x equals 2 and x equals 4 is right here. And so this is what my chopped off graph is going to look like. Let me do it in black. So let me draw it bigger right here. So let's say this is 1, this is 2, 3, 4. And so here, it's going to go between 2 and 4. And so this, when x is equal to 2, this guy is going to be 1/2. When x is equal to 4, this is going to be 1/4. Okay, so this guy looks something like this, right? Okay, and so it's between 2, 4, and y equals 0. And if I rotate it about the x-axis, so let me draw, this might help visualize. So pretend you have this guy and you rotate it around. So pretend the the x-axis is like a rod and you're rotating this around. So what you're going to get is this is going to reflect completely across, and we're going to end up with something that looks kind of like a trumpet. Okay, so this is the surface of revolution that I want to find the volume of. And so remember, the whole idea behind this is that we need to find a formula for the area of the cross section. Because once we find a formula for the area of the cross section, then the volume is going to equal the integral from start to finish of the area. And you have to decide to integrate with respect to x or y. Now this time, if you take a look at this, the cross section that I would choose would be a slice, a circular disc, a little slice right here. And this purple disc, since it's perpendicular to the x-axis, so when we integrate, we're going to sweep through in the direction of the x-axis. So the area is going to be with respect to x. Okay, and then I'm going to integrate from start to finish. So it starts at 2 and ends at 4. And remember, all of these should match. So if we're integrating with respect to x, then the 2 and the 4 should represent x values. Okay, now let me blow up this purple disc over here. So this disc So this is a circular disc, and with a radius of we'll call it little r. And so to find the area, well, the area is pi, the area is equal to pi r squared. Now, I need to figure out a way to write down the radius in terms of my variable, which in this case is x. And so if you take a look at this, let me put down the axis here. So this is going to be, this is the coordinate axis. And so this is going to be x. And so notice that r, the value of the radius, is simply the value of the function that I use to graph it. So the radius is actually simply 1 over x for every x value. Okay, so then the formula for the area with respect to x is going to be simply pi times 1 over x squared. And so this solves, pretty much solves my problem. And this is the hardest part, the setting it up, because now I can do my integral for the volume. So what I want is to find the integral from 2 to 4, like I had up here, of pi times 1 over x squared. Why don't I, since I'm going to get the integral, I'm just going to write it as x to the negative 2 dx, so that I could use the power rule. Okay, so this is simply equal to pi x to the negative 1 divided by negative 1 by the power rule. And this is going to be evaluated from 2 to 4. And so this is equal to minus pi. I'm just going to factor out the minus pi. And then I'm going to have, if I plug it in 4, it's going to be 1 over 4 minus 1 over 2. And then this is just equal to positive pi over 4. Because 1/4 minus 1/2 is negative 1/4. And with this negative, it turns out to be positive. So this is simply pi over 4. And that's it.